Hello students, welcome back. We completed chapter number 1 and today we'll be moving on to chapter number 2, and that is polynomials. Okay. Polynomials, have you ever studied about them? Okay. Before telling you about polynomials, let's divide maths into three parts. Mathematics is divided into three parts: algebra, arithmetic, and geometry, right? So now for this chapter we'll be studying algebra, right? Now, algebra is made up of two parts: constants and variables, right? Algebra is all about polynomials, how you make a given condition into a mathematical equation. That's algebra, right? That is a polynomial also. How you that equation is called the polynomial, and how you make a given condition. Let's say Vishal's age is twice the age of his sister, right? So if my age is x, then then his sister's age will be x upon 2, right? So that's simple algebra, how you make the given condition into an equation. Constants and variables: 2, 3, 4, 5, 1000, these are all constants. Whereas variables, any number whose value varies with condition. Any number whose value varies with condition, right? So that is a variable. Now we'll be studying about these variables. These variables, when expressed in a condition, are known as polynomials. What are polynomials? When variables are expressed in any condition, that is known as polynomial. Simple: x square, that's an algebraic expression, and that is a polynomial. X cube plus x square plus x plus 1 plus 2x plus 7x, that is another polynomial, right? So you can just say x to the power 100 plus x to the power 99 plus 1 upon x. That is another polynomial, I hope so, right? So these are all polynomials, the example of polynomials. Now polynomials are also known as algebraic expression, of course. So right, we have studied about polynomials in one variable, polynomials in two variable. What does that mean? Polynomials in one variable, when in a given condition we have just one variable, let's say 2x, or 2x square plus 1, or 3x cube plus 3x square plus 3x plus 3. So we have just one variable x, right? X square and x cube will give us different values, but the variable here that is utilized is x. So that is known as polynomials in one variable. Polynomials in two variable: example 2xy, 3xc, 7x square y square, right? These are all polynomials in two variables. Or further examples are 7x plus 3y, that is another example of polynomial in two variables. So this is how, if the number of variables increase, it will be three variables. If it will be 2x x plus y plus z, or x y z, simply this is a polynomial in a three variable. Okay, one variable, two variable, and three variable. Coming to, these are a few concepts that will be requiring further. So in a polynomial there are two parts again. In an algebraic expression, you have two parts. Let's say if this is an expression x square plus 2x plus 1, right? So this first part, second part, third part, sorry, it doesn't have any parts actually. Of course it is a constant and a variable, that was it. But the different things that have been written in between the mathematical operation plus or minus, these are called as terms. What do we call it as? Term. This is another term, this is another term. So here there are three different terms. If x square is taken, for x square, what is the coefficient? X square, it doesn't have anything, that just means the coefficient is 1. So that is another coefficient, that is another word that is utilized here. The value, the constant value that has been written before the variable. What is the coefficient? The constant value that has been written just before the variable. Okay, so here is a variable in any term, in a term. We always see the coefficient of a term, right? The equation, in equation, if it has been asked n, x, y, z, what is the coefficient for y? Okay, so it will be 9x, z. What will be the coefficient of what? That is just the coefficient. Now I ask you, what is the numerical coefficient of y? That is simply 9. Okay, so numerical coefficient, you will just write the numerical value. If it has been written what is the coefficient for y, you will write 9x and z. If the coefficient of z, then 9x y. Okay, that's easy, of course, the term and coefficient. Okay, now this is it. There is this term constant polynomial again. The thing that I told you in the very first part, that is constant and variable. Constant 2, 5, 7, 7.1, 5, 6, 4, 3, anything. These all are constant values and they are called as constant polynomial. Okay. 0 is the exception. 0 is an exception. This is called as zero polynomial. What do we call it as? We call it as zero polynomial. Okay. It doesn't have a term, it doesn't have a coefficient. 0 is just zero polynomial. Okay, moving on. Further things that I need to tell you is what are monomials, binomials, and trinomials. Okay, monomials, binomials, trinomials. So monomials is single term polynomial. Okay, single term expression, single term expression. Example 2x, y, z. This is simple, single term. We don't see the variable here, we see the term. There is no mathematical operation plus or minus. That's just simple 2x, y, z. That is single term variable. That is a monomial. 2x square y square plus 3z square a square. Okay, that is another. Here are two terms, first term, second term. They are called as binomial. Bi means two. Try, three, of course. 3 term expression is called a trinomial. Example x square plus 3x plus 7. Simple trinomial example, right? So that is a trinomial. Okay, now these are important, you must know them: monomial, binomial, and trinomial. Okay, moving on, degree of a polynomial. The degree of a polynomial is the highest power of any variable in a term. The highest power of variable in a term. Okay, so that is degree of a polynomial. For example, if you take x cube 5x to the power 4 plus 7x square, then the degree of this particular polynomial is 2. Am I correct? Nope. Is 3. Am I correct? No. The highest power, I hope so, is 4. The degree is 4. Okay, you must see that. The second part, another kind of example that will come: x cube y plus 5 x square y square plus 5 x y 5. Okay, right? This is an example. So what we see is that we will add the power of the variables in here. Y has a power of 1. If there is nothing written over it, it has a power of 1. So of course the maximum power here is 4. Again the maximum power here is 4, but here the maximum power is 6. So the degree of this particular polynomial is 6. Okay, easy, right? So that is the degree of a polynomial. Now we have studied about factorization and all. We have studied about linear equation, quadratic equation and cubic equation. We will be seeing what are those. Okay, the another little concept, types of polynomial on the basis of the degree, on the basis of their power. Linear polynomial, it may be of single variable, it may be of double variable, it may be of triple variable. Now linear polynomial, the only thing that we have to keep in mind is that the highest power in linear polynomial is 1. It may have any number of variables, but it doesn't matter, the highest power is 1. Let's say 4x plus 5y. Simple. That's a polynomial, of course, but it is a linear polynomial. The highest power is 1, right? Second is quadratic equation, quadratic polynomial or quadratic expression where the highest power is 2. Simple, right? And then there is cubic polynomial. The highest power is 3. Example. The fourth one is by quadratic expression or polynomial where the highest power is 4. Okay, easy. Here the thing that I have written is plus. Okay, we have these 3 in our syllabus. Biquadratic is, just for your knowledge, what do we call the higher powers, of course, biquadratic. And then when you grow up to be in graduation or something, you'll get a lot number of series. There will be this Taylor series and all. So for 9th and 10th up till here, linear, quadratic and cubic polynomial. Okay. Now we'll be moving on to the exercise number 2.1. Okay. Okay, just one more question. If we have an expression 5, what is the degree? Can anyone tell me? Of course, if it would have been 5x, the degree would have been 1. Here it's written 5, the degree of any constant is 0. You will write it in a note. The degree of any non-zero constant, that means except for 0, any other number will have is 0. Okay. So if it is a non-zero constant, it's 0. What is the value of the degree of 0? 0, which is not a expression, it is called 0 polynomial in itself. So the degree of 0 polynomial is not defined. We do not have a value for the degree of a 0 polynomial. Not defined, it simply go for the literal meaning of it. It's undefined. We don't know the value of the degree of 0 or a 0 polynomial. Okay. So now moving on to exercise number 2.1. On the basis of the basic concepts, we'll be doing exercise number 2.1. It will be done in like 5 to 10 minutes max to max, and it's a very easy exercise, of course. Just the thing that you'll have to keep in mind is the concepts. Okay, you must keep in mind the concepts that I just gave you. I hope you're writing it down. Okay, it is necessary actually. So the first question is in exercise number 2.1. I'm writing it here. It's exercise number 2.1. The very first question is, which of the following are polynomials in one variable and which are not? State reasons for your answer. Okay. So now one thing that you must keep in mind, of course, we'll come to this part again later. But first, when is a polynomial, when is an expression said to be a polynomial? Okay, I'm writing two different cases. Okay, three different cases first. X square plus 5 under root of x plus 5, 1 upon x plus 5. Okay, so what we'll do is that we will bring this in the form of a polynomial, in a linear form, in a quadratic form, in a cubic form, whatever form we can do, in an exponential form actually. Okay, so here x square plus 5, it is in exponential form. X has it in exponential form. Here x whole 1 upon 2, since the square root is 1 by 2, plus 5. This is not okay. So exponential form again. This can be written as 1 upon x. 1 upon x can be written as x to the power minus 1 plus 5, indices, exponents. This here, x has a power which is a whole number. Hence, this is a polynomial. X here has a power which is not a polynomial. It is in the form of a rational number 1 upon 2. Hence, this is not a polynomial. Here x doesn't have a power which is a whole number, right? It is a integer, negative side. Okay, so it is also not a polynomial. So an expression needs to be polynomial. An expression is a polynomial. An expression, you will just write it down somewhere in your copy. An expression is a polynomial when x, or the variable, here we are taking x, we'll write when the variable has a whole number power or exponent over it, right? Example, the best examples are x square plus 5, root x plus 5, and 1 upon x plus 5 here. So what we do is that we convert it into the exponential form. This is given in the exponential form. We convert root x to the power 1 upon 2 and x to the power minus 1. So we see here this is a whole number, this is not a whole number, and this is again not a whole number, it is an integer. Hence these two are not polynomials, but this is a polynomial. This concept will be utilized in the first question. Okay, right? I missed that part, so I just gave you right now. Now moving on to exercise number 2.1. Now it will be very easy for you to choose which of them are polynomials or which of them are not, and you know the reason. Of course, I'm just going to write which of them are polynomials or which of them are not. The reason I'll be telling you, so listen carefully. Okay. So 4x square minus 3x plus 7. What is the question? 4x square minus 3x plus 7. So x here again has a whole number power, x here again has a whole number power, therefore yes, it is a polynomial. You know the reason? Because the variable has a whole number power. Okay, simple. Third, y square plus root 2. The variable has a whole number power. It doesn't matter if the constant part has it or not. The variable has a whole number power. So yes, it is a polynomial again. Coming to the third part, 3 root t plus t root 2. In the second term here, it does not have it has a whole number part, but in here root t, square root t to the power 1 upon 2, it does not have a whole number part, whole number power. Therefore, no, it is not a polynomial. You know the reason what you'll write? You'll write t does not, or the variable in the first term does not have a whole number exponent or whole number power. Hence, it is not a polynomial. That is the reason. Okay. And there is it has been asked, state reasons for your answer. The fourth question is y plus 2 upon y plus 2 upon y. So here again 2 upon y to the power minus 1, hence it is again, no, it is not the power. So what you can do is also, if you don't want to write any language, you'll just say y plus 2 upon y, or y plus 2 into y to the power minus 1. Here it has a negative integer in here, so it does not have, it is not a polynomial. Coming to the third part, x to the power 10, fifth part, x to the power 10 plus y to the power cube plus t to the power again 50 it is, or 60, 50. So here it is a polynomial of 3 variables which have a whole number power. Therefore, yes, it is a polynomial. Simple. Okay. Moving on to the second question. We just need to write the coefficients. Okay. Easy. The first part was very easy actually. You need to move on with the concepts. Second, write the coefficients of x square. It has been asked particularly what is the coefficient of x square. So we'll be writing the first question 2 plus x square plus x. That's the first question, I hope so. Yeah, that's the first question. Where's x square? X square is here. Nothing is written in before x square. So what is the coefficient? It's 1 there, okay? It cannot be 0 because if 0 is multiplied to x square, it's 0. The whole term will be 0. But x square is there, therefore that's 1. So what is the coefficient of x square? Here it is 1. What's that? It's 1. I haven't written the full word coefficient, just mind that, okay? Second, 2 minus x square, 2 minus x square plus x cube. You know, keep in mind these symbols also, these symbols, okay? Here, coefficient of x square is minus 1. Minus is negative of 1, okay? Negative sign is here, therefore it is negative of 1, okay? Keep that in mind. Now, moving on to the third part, pi upon 2 x square plus x. X square here, what is the coefficient before them? The constant value is pi upon 2 and that is the coefficient, okay, for the third part. Easy. Moving on to the fourth part, root 2x minus 1, I hope so. Yes, of course. Root 2x minus 1. Now there is no x square in here, is there? We have to find out the coefficient of x square. Therefore there is no x square, hence the coefficient here is no x square. That just means 0, because 0 into x square will give us a 0, okay? So you can just rewrite this as 2x minus or plus 0 into x square minus 1. You will get the coefficient here, or you can just see there is no x square, you can just write coefficient is equal to 0. Okay, if you didn't understand why did you write the coefficient 0, therefore that's the answer of it, because 0 plus x square, there is nothing in here, so 0. Okay, moving on to the third part of exercise number 2.1. Now give an example each of binomial of degree 35. Binomial, an expression with two terms, okay? Two terms, an expression with two terms. I wrote two terms, but with a degree of 35. So y to the power 17, that's the highest degree, it becomes 17, but I am asking about a binomial with a degree 35. Therefore this is the binomial with degree 35. Degree is the highest power of that particular expression, okay, for the first. And second, monomial of degree 100, y to the power 100, 2y to the power 100. Simple, okay? So anything, it can be anything. These questions may vary. You can take x, y, z, a, b, c, d, any number, any value, any variable that you want, and you can place 100 over it, and that will be your answer. Okay, it is not necessary that this answer may tally with you, because you can choose any different alphabet. Okay, no need to get confused. Moving on to question number 4. Write the degree of each of the following polynomials. We have to write the degree of each of the following polynomials. We know what's the degree. Degree is the highest power of that particular expression. So moving on to the fourth part, the first question is 5x cube. So it is 5x cube plus 4x square plus 7x. I hope so. That's it. Yep. The second question is 4 minus y square. The third question is 5t minus 7, 5t minus under root of 7, and then there is the fourth part, that is 3. So here the highest power is 3, of course, so degree is 3 simply. Here the degree is 2, the highest power is 2. Here the degree is 1, of course, the highest power is 1. It is a constant value, therefore degree is equal to 0. The degree of a non-zero constant polynomial is 0. Of course, if you get confused with this 0, I'm writing it properly. Okay, 0. Okay, easy. Moving on to the fifth part. That is your degree. I've actually told you while giving concepts these all things. You have to tell which of them are linear, quadratic, and cubic polynomials. Of course, a polynomial with a degree 1 is called a linear polynomial. Okay, the first question is x square plus x, it has a degree of 2, it is a quadratic polynomial. Quadratic polynomial. Okay, the second part, x minus x cube. The third part, y plus y square plus 4, y plus y square plus 4 again. Fourth part, 1 plus x. Fifth part, 3t. Sixth part, r square. And seventh part, that is 7x cube. So what is here? Cubic polynomial. Here again is quadratic. Here again is linear. Here again linear. This is quadratic. And this is cubic. Easy? Of course, it's actually very easy. Now, we'll be moving on to exercise number 2.2. But before moving on to 2.2, I'll have to give you some concepts. Concept about finding the zeros of a polynomial. So what do you mean by that? Zeros of a polynomial thing. Okay, zeros of a polynomial. This is again concept. Zeros of a polynomial. Okay. Let's say we take any expression 5x cube minus 2x square minus, what is it, plus 3x minus 2. For what value of x? For what value of x will this expression give 0? That value is called the zero of the polynomial. Okay. For which value? Whichever value we may put it there. It may be a heated trial method. We can put 1, we may put minus 1, we may put minus 2, we may put 3, 4, 5, 6, whatever it is. So let's say we put x is equal to 1. Okay. And we see 5 into 1 bracketed cube minus 2 1 bracketed square plus 3 bracketed 1 minus 2. So we have here is 5 minus 2 plus 3 minus 2. So what it is? 5 and 3 is 8, minus 2 and minus 4, 4. Therefore, x is equal to 1 is not a 0 of the polynomial. So that is how we will find out whether any number is a 0 of a polynomial or not. Okay. Now, we'll be doing many questions and we'll be seeing whether they are zeros of a polynomial or not. Okay. So this was not a 0 of the polynomial. This this is the simple concept that will be utilized in exercise number 2.2. So let's say we have x plus 2, a simple expression. Okay. And I'm asking you to find out the zeros of the polynomial. We'll see this value 2. Okay. So what can be? Plus 1, minus 1, plus 2, minus 2. These are the numbers that can come here. The factors of 2. We'll write the factors of 2. So we'll place here x is equal to plus 1. So we'll put plus 1 plus 2. It comes out to be plus 3. Hence this is not the 0 of a polynomial. X plus 2 will place minus 1. So minus 1 plus 2 is again minus 1. That is not the 0 of a polynomial. X is equal to minus 2 plus 2. It comes out to be 0. Therefore, x is equal to minus 2 is the 0 of a polynomial. Okay. Simple. That's it. We have to find out the zeros of the polynomial. This is how we find out the zeros of a polynomial. Okay, kids? So, now moving on to the exercise. Exercise 2.2. Find the values of the polynomial 5x minus 4x square plus 3. So we have been given an expression 5x square. Okay, it's 5x minus 4x square plus 3. At x is equal to, the first part is 0. The second part is at x is equal to minus 1, and third part is x is equal to 2. At x is equal to 2. So if x is equal to 0, what will happen? 5, 0 minus 4 into 0 square plus 3. So this comes out to be 5 into 0 is a 0. 4 into 0 again is a 0 plus 3. The value comes out to be 3. Similarly, you will be doing this and you will be doing this. In negative, what will happen? 5 into minus 1 minus 4 minus 1 whole square plus 3. If it is a difficult one, 5 into minus 1, put it minus 5 minus 4 into 1, minus 1 into minus 1. What you do is that minus 1 into minus 1, never ever neglect the symbol. Minus 1 into minus 1, it will give you a 1. 4 into 1 is minus 4 plus 3. That just comes out to be minus 5 and minus 4 is minus 9 plus 3. It is equal to 9 and 3, 6, negative. Same symbol numbers get added up. Same symbol numbers get added up. Opposite symbols get subtracted. Remember that. Okay. So that is our third part is all yours. Okay. Moving on to the second question of this exercise. Let's see what the question is. Find p, 0, p0, p1 and p2. What are these p0, p1, p2? Let's say I write an expression. The question given here is py is equal to y square plus or minus y plus 1. Okay, so this is y square minus y plus 1, of course. That is the question here. Py means p is a polynomial of y. Simple. P is a polynomial of y and the polynomial is this. That's simple. Okay. So what I am doing is that we have been asked to find out the values of p, 0, p, 1 and p, 2. So what that means is that we'll have to put the value of y here as 0. So the value comes out to be 0 square minus 0 plus 1. 0 minus 0 plus 1, it is equal to 1. Or the value of y is equal to 1. So it comes out to be 1 square minus 1 plus 1. 1 square is 1 minus 1 plus 1. Minus 1 plus 1 gets cancelled out. The value again is 1. Y is equal to 2. So 2 square, we are substituting the value of 2 y in here. Minus 2 plus 1, it comes out with 2 and 2 is 4 minus 2 plus 1. Opposite symbols get subtracted. 4 minus 2 is 2 plus 1. Same symbols get added up. 2 plus 1, 3. Okay. Easy. That is how you'll be finding out the other questions. Other parts of question number 2. It's easy. You just have to substitute the value of t in the second part. You just have to substitute the value of x as 1, 2 and 3 in the third. Okay, 0, 1 and 2 in the third part. And in the fourth part also you have to substitute the value of x as 0, 1 and 2 in three different conditions, of course. Okay. Now moving on to the third question. Verify whether the following are zeros of the polynomial indicated given against them. So it has been given that third question, first part. So it has been given, the question is px 3x plus 1. That has been given to us, of course. And x is equal to minus 1 upon 3. That just means if we put the value of x in here and if p 1 upon 3 is equal to 0, then this is the 0 of a polynomial. Okay, let's see what I'm saying. So what I do is that p x is minus 1 upon 3, so we'll write p minus 1 upon 3. What will be the value? 3 bracket minus 1 upon 3 plus 1. We always use a bracket. 3 into minus 1 is minus 3 whole upon 3 plus 1. 3 1 times, 3 1 times. What comes? Minus 1 plus 1, it is equal to 0. Therefore, yes, x is equal to minus 1 upon 3 is a 0 of the polynomial. Okay kids, easy. That is how you will be doing the other 8 parts. Okay, I will be choosing some of the difficult parts like the 7th one. Okay. The second part, it's easy. You just have to put the value of x there and see whether whether the value comes out to be 0 or not. In the third part, you have to put once you have to put the value of 1 and once you have to put the value of minus 1. Okay, I'll solve that. Question number 3, third part. So it is px x square minus 1, that is where x given is 1 and minus 1. So what we will do is first we will take the value p1 and second time we will take the value of p minus 1, whichever satisfies. 1 is square minus 1. 1 is square is 1 minus 1, that value is 0. Therefore, x is equal to 1 is a 0 of the polynomial. Let's say we take minus 1 is square minus 1, just substituting the value of x there. So minus 1 is square is 1 again, minus 1, it comes out to be 0. Therefore, yes, x is equal to minus 1 is also a 0 of the given polynomial. Easy. In the fourth part, same, we'll put the value of x is equal to minus 1 first and then x is equal to 2. In the fifth part, px is equal to x square, we'll substitute the value of x is equal to 0 into that particular equation. In the sixth part here, we have the value px is equal to lx plus m. Okay, I'll be doing the sixth part here. Px is equal to lx plus m. That is the equation, I hope so. Yes sir, that's it. And the value of x that has been given to us is x is equal to minus m upon l. So what we'll do is that we'll substitute the value of x in here. So we'll write here p minus m upon l. It is equal to l into minus m upon l plus m. We can just see it, minus m into l whole upon l plus m. L and l gets cancelled. It comes out to a minus m plus m. It is equal to 0. Yes, of course, this is the 0 for this polynomial. Okay. Moving on to the seventh part. Seventh part is also easy. You just try doing it and you will get the value, right? Eighth part, it's the same. Px is equal to 2x plus 1 where x is equal to 1 upon 2. So you will put the value of x is equal to 1 upon 2 into that particular equation, and if it is equal to 0, then x is equal to 1 upon 2 is the 0 of the polynomial. Moving on to the fourth question, find the 0 of the polynomial in each of the following cases. Okay, how to find the 0 of the polynomial? Okay, so that's your fourth question. The fourth question is find the 0 of the polynomial in each of the following cases. Okay, so we have this first part, p x is equal to x plus 5. That's it, simply. So what will happen if in order to find out, this is a simple note that I am giving. You must keep it in mind in here and your copy so that it will be utilized in your future purposes. In order to find the 0 of a polynomial, equate the given equation to 0. Okay, you'll get the value of the variable. Okay, what will happen? You will get the value of the variable. Okay, so what is the thing that is saying here? So the thing that I am saying here is the solution of this is here. Px is equal to 0. We equate the given equation to 0. So x plus 5 is equal to 0 or x is equal to minus 5. So x is equal to minus 5 is the 0 of the polynomial. Okay kids, that's easy. Okay, moving on to the second part. The second part, Px is equal to x plus 5. Px is equal to x minus 5. Equate this to 0, we will be moving on stepwise. Px is equal to 0, x minus 5 is equal to 0, x is equal to 5. So this is the required 0 of a polynomial. Moving on to the second, third is easy, fourth it's also easy. You will equate 3x minus 2 is equal to 0. So 3x is equal to 2 because 2 will move on to the other side, and then x is equal to 2 upon 3. The fifth one, Px is equal to 3x. Px is equal to 3x. That just means if you equate the given equation to 0, then 3x is equal to 0 or x is equal to 0 upon 3, or that is 0 simply. Okay. The other part, sixth part, that is the same thing. Px is given to be equal to ax, where a is not equal to 0. A is non-zero, of course. That just means if you equate Px is equal to 0, that ax is equal to 0, then x is equal to 0 upon a. Any number dividing 0 is 0. Therefore, this is another 0 for that particular polynomial. Okay. Moving on to the seventh part. Seventh part says we have these two equations. Px is equal to cx plus d, right? So what will happen? Where c and d are integers, real numbers, of course. So p x is equal to 0. We are equating this equation to 0. So cx plus d is equal to 0. Cx is equal to minus d, or x is equal to minus d upon c. So this is the 0 for this particular polynomial. Easy. And that is how you find out the 0 of a polynomial. And this is where our chapter or our exercise ends. Okay. So exercise number 2.2 was all about 0 of the polynomial, and we just learned how to find out the 0 of a polynomial. Okay. Right. Or whether a number is a 0 of a polynomial or not. Okay. So this is for today's session. Of course, a lot to learn and to revise. So I would like you to do these questions again in your copy. Okay. And do all the examples, of course. What? Do all the examples, and that will be for today. Okay. So thank you.